Now let's look at the number 8. Cosine x over the secant x plus the sine square x. Since we need to use the sine and cosine to rewrite those trigonometric functions which are not sine and cosine. So first, let's replace this secant x by 1 over the cosine x, right? This is the reciprocal identity. So you have the cosine x divided by 1 over the cosine x. Tell me, what is this? What is this? Is this equal to 1? This guy and this guy cancel? No, right? Because this is not the cosine x, it's the 1 over cosine x. So actually, you need to multiply both the numerator and denominator by the cosine x, and then you get the cosine square x, right? So now you get the cosine square x and plus sine square x. Then use the fundamental identity, you get what? Now let's see how we use the identities to rewrite any of the 6 trigonometric functions in terms of any other. So for those 6 trigonometric functions, we may rewrite any of the those 6 trigonometric functions in terms of any other. So right now, let's look at the such example. Rewrite sine in terms of cosine. So to write sine in terms of cosine, we need to begin with one identity involving both the sine and cosine. Which identity should I use? Which one? How about this guy? Fundamental identity, right? We begin with the fundamental identity because this identity involves both the sine and cosine. And then we may just solve this equation, this identity, for sine in terms of the cosine. So you have the sine square x plus the cosine square x equal to 1. So right now we need to write the sine in terms of cosine. Then we just move this cosine square x to the right. And then we get the sine square x equal to 1 minus cosine square x. Then we take the square root of the both sides. Then you get sine x equal to plus minus the square root of the 1 minus the cosine square. And here this plus minus sign, this plus minus symbol means if sine x is positive, then the identity is sine x equal to the positive square root of the 1 minus the cosine square x. And if the sine x is negative, then you have the identity sine x is equal to negative square root of the 1 minus cosine square x. let's look at another example. Write an identity that expresses the cotangent function in terms of the sine function. Now this time, tell me which identity should I begin with? Your identity must involve both the sine and cotangent, right? Tell me which identity should I use? So one of the Pythagorean identities, right? So you have the cotangent square x plus 1 equal to the cosecant square x. You may say, oh, this identity only involves the cotangent, no sine, right? Yes. We don't have sine here, but we may rewrite this cosecant square x as the reciprocal of the sine square x, right? So from this identity, by using the one reciprocal identity, then we got cotangent square x plus 1 equal to 1 over sine square x. And since we need to write the cotangent in terms of the sine, so we may move this one to the right side. Then we get cotangent square x equal to 1 over the sine square x minus 1. And then you simplify this right side. This guy is equal to 1 minus the sine square over the sine square. We just reduce these two numbers to the common denominator and then subtract, right? So you have the sine square x over the sine square x equal to 1. Okay, and then you take the square root of the both sides. You get the cotangent x equal to plus minus the square root of 1 minus sine square x over the sine square x. And then you can take this sine x out. So you get plus minus. Since we already have the plus minus sign here, we don't care about the sign of the square root of the sine square x. So you have the square root of the 1 minus the sine square x over the sine x. So actually, you may also start with another identity from definition and then use the one of the previous results to express this cotangent x in terms of the sine. You know, cotangent x is equal to cosine x over the sine x, right? And we just got the cosine x is equal to plus minus the square root of the 1 minus the sine square x. So then you get replace this cosine x by this plus minus square root of the 1 minus the sine square x. Then you got square root of the 1 minus the sine square x over the sine x. So you got the same result, okay, by using these two different identities. Any question? Now let's talk about the problem 20 on the page 516. And we need to write the cosine x in terms of the tangent x.